Good day, students. You are welcome to your favorite YouTube channel, Physics for Everybody. Today, you'll be working on physics IGCSE past question on the one for October-November series, year 2022, paper 1, which is mainly the core question. So the duration of this exam is 45 minutes. Hence, we try to limit our solution to less than 45 minutes. Let's go straight to question number 1. The times for 10 swings of a pendulum are measured. So each of these represents 10 swings. The second one is 10 swings, the third one is 10 swings. Now you are asked to calculate what is the average time for one swing. You know, each of these is 10 swings, 10 swing, 10 swing, 10 swings. That means the total for these three is 30 swings, right? Good. So if you add these three together, all of this, if you add them together, you get the total time for 30 swings. Now let's add 10.12, 10.12 plus 10.48. 10.12 plus 10.48 plus 10 point, let's see the last value, plus 10.24 plus 10.24. All of this gives you 30.34. Now this 30.34, we are going to divide it by 30 because there are a total of 30 swings. And this gives us 1.028. And this is option A. So you shade A. Question 2. A car starts from rest. The table shows the reading from its speedometer every 10 seconds. Which role describes the car's motion in the first 30 seconds and in the last 30 seconds? So now this row here shows the time, and the first 30 seconds would be from here to here. So during the first 30 seconds, take note that the speed keeps increasing by a factor of +4. Okay, 0 plus 4 gives you 4. 4 plus 4 gives you 8. Okay, you keep adding 4. You keep adding 4 again. So since you are adding a constant value, since the speed is increasing by a constant value for equal time interval, then we know that the acceleration is constant. Okay, so the acceleration is constant. That means the car is accelerating. Now look at the last, during the last 30 seconds. Now for the last 30 seconds, what do you notice? Here, the speed is constant during the last 30 seconds. So since speed is constant, that means there's no acceleration during the last 30 seconds. Okay, so for the first 30 seconds, there is acceleration. Okay, there's an acceleration. For the last 30 seconds, there is no acceleration. So if you look at the option D is the correct one. It shows that non-zero acceleration, which is correct. Okay, there is non-zero acceleration during the first 30 seconds, and there is constant speed. Yes, you see the speed is 12 meters per second throughout the last 30 seconds, and that is what we mean when we say constant speed. Hence option D is the correct answer to this question. Let's move to question 3. A stone is placed on a balance as shown. The mass of the stone 20 milligram. Which rule gives the mass and weight of the stone? If the mass of the stone is 20 milligram, you know sorry, 120 milligram is 120 gram rather, not milligram, pardon me. The mass is 120 grams. Now we convert this mass to kilogram. Okay, and to convert from grams to kilogram, we are dividing this value by 1000. Okay, this will give us the mass in kilogram. So 120 divided by 1000, what will that give us? That will give us 0.12 kilogram. That's the mass. Okay, that's the mass of the stone. And what's the weight? The formula for weight is that weight is equal to mass times the gravitational field strength of the earth, and gravity is 10 meters per second square. So let's multiply our mass by gravity. The mass is 0.12 multiplied by gravity. Gravity is 10. 0.12 multiplied by 10, that will give us 1.2 Newton. So the mass is 0.12 kilogram and the weight is 1.2 Newton. And that is option. Okay, we don't even need the mass in kilogram. Let's leave our mass in grams. Our mass is 120 grams, yes. Okay, and our weight is 1.2 Newton. Okay, the reason why I'm using our mass in grams is because all the options here put the mass in grams. So I'm using that. So our mass is 120 gram, weight is 1.2 Newton, which is option A. Option A is the correct answer. Let's move straight to the next question. I'm supposed to wipe this off, but in order to save time, I'll leave it here. Okay? You don't need to write all of this during your exam. Just shade your correct answer. Now, question 4. The diagram shows the dimension of solid rectangular block of metal of mass m. Which expression is used to calculate the density of the metal? The formula for density is that density is mass divided by volume. And what's the formula for volume of a cube? This shape is a cube. Volume is length times breadth times height. Okay, but in this case, we have the dimension. We have the length as P, we have the breadth or the width as Q, and we have the height as R. So we say our volume is the length, which is P, times the breadth, which is Q, times the height, which is R. Okay, that's PQR. So we substitute for the formula for density. Density equals to mass divided by volume. Our mass is M, okay? M divided by volume. What's our volume? Our volume is what you have here. P times Q times R. So we have P times Q times R. This is the expression that gives us the density of the object, which is option B. So when you shade option B here as the correct answer to this question. Let's go to question 5. A force F acts on an object at a distance x from a pivot. Which two changes both increase the moment of the force about the pivot? Okay, what two changes will increase moment of the force? You know, moment is equal to force multiplied by distance. So if force is increasing, the moment will increase. Also, if the distance between that force and the pivot is increasing, the moment will also increase. Now look at our option. Decrease F, no. Decrease F, no. Increase F, decrease X, no. Increase F, increase X. Perfect. Increasing force and increasing distance, they will increase the moment. Okay, this question should be on resultant forces. Question 6. The diagram represents two forces acting on an object. Which object could be moving to the right at constant speed? Okay, so for an object to be moving to the right at constant speed, that means the resultant force must be to the right. The resultant force must be acting towards the right, okay? Yeah, that means your force resultant must be acting to the right. So in which case do you have the resultant force to the right? In option A, both the force to the left and the force to the right, they are balanced, they are equal, so the object stays at one position. Option B, the two forces are directed to the right, that means the resultant force will be to the right. In option C, the force to the left is bigger than the force to the right, okay? The force to the left is 2 Newton. The force to the right is 1 Newton. 2 minus 1 gives you 1. So there will be a resultant movement to the right in option C. In option D, the force to the right is 2 Newton. The one to the left is 1 Newton. 2 minus 1 gives you 1. The resultant will be in the direction of the bigger force, which is the 2 Newton force. So the resultant will be a force acting towards the right. So in this case, the only case where the resultant is to the right hand side, which object could be moving to the right at constant speed? So now, in the only case where we have an object, okay, now we have to consider something else. For an object to be moving at constant speed, that is one thing that we need to consider. If the object is moving to the right at constant speed, that means there will be no resultant force. Okay, that means the resultant force equal to 0. Why? Because force is equal to mass times acceleration. If something is moving at constant speed, if the speed is constant, okay, at constant speed or at constant velocity, acceleration is equal to 0. Okay, so when acceleration is 0, by the time you do force is equal to mass times acceleration. When you multiply the mass by your acceleration of 0, you have a resultant force of 0. So the only case where the speed is constant is when the resultant force is 0, which is option A. I hope this is clear. Yeah, so the only case where you have the resultant force to be 0 is option A, and that's the only condition where an object will travel at a constant speed. Okay, if the resultant force is not 0, then the object will not travel at constant speed. The object will be accelerating or decelerating. Question 7. The diagram shows a uniform rod with its midpoint on a pivot. Two weights x and y are hung from the rod. The rod is in equilibrium. Which statement is correct? The force at x and y are different values, and that's not a necessary condition for the rod to be in equilibrium. Okay, it was said that the rod is in equilibrium. Option B, there's a resultant turning effect on the rod. This means the rod is not even in equilibrium at all. Option C, the resultant force on the rod is 0. This is a necessary condition for something to be in equilibrium. Option B, the rod does not have a center of mass. No, of course the rod will have a center of mass. So option C is the correct answer to question 7. So we shade option C. Question 8. Brakes are used to slow down a moving car. Into which form of energy is most of the kinetic energy converted as the car slows down? When you apply the brakes on your car and you're trying to slow down your car, the brake pad will grip onto the wheels of the moving tires, and that would create friction. And friction produces what? Friction produces heat. So it is thermal energy. Okay, thermal energy is the energy that is as a result of heat. Question 9. What is a disadvantage of nuclear fusion as a source of energy? Option A. Nuclear power stations are expensive to build. That's correct. Nuclear power stations are expensive to build. Option B. Nuclear power stations are unreliable. No. Option C, nuclear power stations can only provide small quantities of energy. No, that's not correct. Option D, nuclear power stations release large quantities of carbon dioxide. No, nuclear power stations do not release carbon dioxide. So option A is the only correct answer. Question 10. The statements describe what happens when the power of a machine is increased. 1. The work done in a given time decreases. Work done in a given time decreases. No. Number 2, the work done in a given time increases. Good. That's what happens when power increases. See, number 3, the time taken to do a given quantity of work decreases. No, it should decreases. Yes. The time taken to do a given quantity of work decreases. Correct. Number 4, the time taken to do a quantity of work increases. No. When power is increasing, then you need little time to do the same quantity of work. Okay, good. Which statements are correct? 2 and 3. Where do you have 2 and 3? C is the correct answer to question 10. Question 11. Which quantities, in addition to the acceleration of free fall g, affect the pressure at the bottom of a pond of water? The formula for pressure in liquid and gases is density times gravity times height. So in addition to density, what else will increase the pressure? You are told that of a given pond of water. So in order to increase, which would affect the pressure at the bottom of a given pond of water. All right, let's see the density. Let's see the density of the water. The density of the water and the depth of the pond only. Density and depth. That's correct. Density and depth. That's correct. So option A is the correct answer to question 11. Let's go straight to question 12. A fixed mass of gas is trapped in a container. The temperature of the gas is increased, but the volume of the gas is kept constant. How does the change affect the average kinetic energy of the molecules and the pressure on the walls of the container? When temperature of a gas is increased, what happens? The kinetic energy of the molecules of the gas, the kinetic energy of the molecules will increase. Okay, the average kinetic energy will increase. Why? Because when you are applying heat, when you are raising the temperature of a gas by heating it, you are giving more kinetic energy to the molecule. So the kinetic energy would rise. Also, the pressure would also rise. Yes, according to Boyle's law, okay, according to Boyle's law, so considering the relationship between pressure and volume, P1 V1 equals P2 V2. But according to the general Gauss law, P1 V1 over T1 equal to P2 V2 over T2. This simply means once temperature is increased, then pressure and volume are expected to increase. Okay, yeah, so increasing the temperature would raise the pressure. So that makes option increase pressure, increase. Perfect. This makes option A the correct answer to the question. Let's go to question 13. Which rule correctly describes the arrangement of the motion of particles in a solid? What's the motion of particles in a solid? Okay. Option A, arrangement of particles, motion of particles. A, far apart, when the particles of solids are not far apart. It's the particle of gases that are far apart from each other. So A is not correct. B, far apart, not correct. C, tightly packed. Okay, so option C, the arrangement of particles is tightly packed. That's correct. Move randomly from place to place. That is not correct. Option D, tightly packed. That's correct. Vibrate about one position. That's correct. That makes option D the only correct answer. Yeah, because it's only option D that gives us the arrangement of particle is tightly packed. That means the particle of solids, they are very close together and they vibrate about one position. Question 14. What is the temperature difference between the fixed point on the degree Celsius scale? The temperature difference between the fixed points on the degree Celsius scale is upper fixed point minus lower fixed point, and that will be 100 minus 0. Yeah, because the boiling point of water is 100 degrees Celsius and the freezing point of water is 0 degrees Celsius. 100 minus 0 will give us 100 degrees Celsius, and that is the temperature difference. Option B is the correct answer to question 13. Question 14 rather. Question 15. In the diagram, each box represents a state of matter and each arrow represents a change of state. Which row correctly identifies the change of state? Okay, so from solid to liquid state is melting. So arrow should be melting. Okay, so under arrow, we have only these two to be correct. Okay, so from liquid to gas is what is boiling or evaporation. So S should be boiling. Okay, yeah, so these two are correct. Let's go to gas to liquid. From gas to liquid is condensation. So um Q condensation. So this is the only one that is correct. Then let's go to liquid to solid. Liquid to solid is freezing. So P should be freezing. So this is freezing. P is freezing. So option C is the only correct answer to this because it's only in option C that all the options are correct. The rest of them are not correct. Okay, so if you're answering questions of this type, you just have to start from somewhere and then make sure you touch everything. Number 16. Four thermometers with their bulbs painted different colors are placed at equal distances from a radiant heater. Which thermometer shows the slowest temperature rise when the heater is first switched on? The slowest temperature rise, that should be the one that has a shiny surface. Okay, shiny surfaces do not absorb radiant heat. They tend to reflect the radiant heat. Okay, so if heat energy is being sent to me by radiation and my face is has the color of silver and shiny, my face will bounce back those rays. Okay, that's why your mirror that has a silver shiny surface would always bounce back incident rays of light. So incident radiant heat, radiant energy will be bounced back by shiny surface. So shiny white surfaces, yeah. So this one, that's shiny white surface, would be the least to get heated and will be the least to respond. Okay, yeah, because it's slowly increasing its temperature, unlike the dull black surface. Question 17. Which method of transfer of thermal energy is caused by changes in density? Convection. Why? Because convection current is caused by changes in density. You remember when you were dealing with land and sea breezes. Also, when you are dealing with the way heat energy is being transferred within your pot. Let's assume this is your cooking pot, okay, and then you apply heat at one end. Okay, you apply heat at one end. What happen? These are molecules of water. The molecules of water in your pot, when let's assume this is a pot here. When the molecules of water at this end get heated, they rise up. Okay, after rising, what happen? There will be a vacuum here. So the water down here, water molecules down here will come in here to take the place. And the one that rises up will drift this way, okay, in order to return again. So that cycle continues, and the water continues to circulate and circulate and circulate. And that is how heat transfer by convection works. Okay, good. The cycle continues and is due to difference in density of the material. The heated one becomes less dense, and the one that has not been heated will be denser than the heated one. Question 18. The diagram shows two sets of waves in a ripple tank. A student makes two statements about the waves. When the waves reflect from the barrier, the direction changes, but the wavelength remains the same. Number two, Number two, when the waves refract as they enter the shallow water, the direction remains the same, but the wavelength changes. Which statements are correct? Now, when the waves reflect from the barrier, the direction changes, but the wavelength remains the same. During reflection, the direction changes, correct. The wavelength remains the same. That's correct. Number two, when the waves refract, during refraction of waves, as they enter the shallow water, the direction remains the same, but the wavelength changes. That's also correct. This defines refraction of waves, and this defines the reflection of waves. So one and two are correct. So option A is the correct answer. Sorry. When the waves refract as they enter the shallow water, the direction remains the same, but the wavelength changes. That is due to the refraction of waves as they course from one medium to the other. Yes, that is correct. So, where do you have one and two? Option A is the correct answer, okay? Because during the refraction of waves, during the refraction of waves, the the direction might change. Normally the direction would change during refraction of waves, but because in a ripple tank, the the water waves that are being refracted. Oh, sorry, I'm wrong. You see, when these waves come in here, okay, after hitting this barrier, what happen? They emerge in what form? After hitting this barrier, they emerge this way. Yeah. So this one emerges this way. So the direction would actually change. Okay, yeah. So this second one is not correct. Okay, so it's only the first one that is correct. During the reflection of waves, the the direction changes, but wavelength remains the same, and that is reflection. Also, in the case of light wave, if you have a plane mirror here and this is the normal, if you have an incident ray, the direction of the ray will change. Okay, the direction will change. That means the ray has been reflected. Okay, and then during the refraction of rays, okay, let's assume this is the air, this is the normal. Okay, this is the angle of incidence. There will be refraction, that means there will be change in direction. This one here is the angle of refraction. So there will be a change in direction, okay? Good. But the the yeah, there will be change in direction and there will also be a change in wavelength during refraction of rays. So option B is the only correct answer, okay? Because only number one is correct. I hope this is clear. Yeah. Let's go to number 19. Which is the correct order of the colors in a spectrum of white light? In a spectrum of white light, hold on, we have red, orange, yellow, green, blue, indigo, violet. Okay, let's see. Blue, green, yellow, blue, green, yellow. Yes, there's an order here and it follows that order. This one follows the correct order. Blue, yellow, green. Let me use another color for blue, yellow, green. Blue, yellow, green. Okay, you see, you went from here, from first, you jumped here, and then you're coming back here. So this would not work. Yellow, blue, green. Yellow, blue, green. No, no. Well, 1, 3, 2. No, no. This is not working. Then the last one, green, blue, yellow. The last one, green, blue, yellow. Green, blue, yellow. No, no, you don't go that way. So if you're having a correct order, then you just follow a particular trend and you go. You don't jump. Okay, so this one you're jumping. So this one is not correct. Only option A is correct. That's number 19. Question 20. An object is placed 30 centimeters in front of a plane mirror. Which statement describes the image of the object? Option A, the image is the same size and 30 centimeters from the object. That is correct. Option B, the image is the same size and 60 centimeters. No, 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 it must be the same distance. Option C, the image is smaller. No, it must be the same size. Option D, the image is smaller. No, it must be the same size. So option A is the correct answer to question 20. 21. A ray of light is shone onto the surface of a mirror. Which two angles represent the angle of incidence and the angle of reflection? Well, this is the angle of incidence, this is the angle of reflection. So 2 and 3. Option C is the correct answer. Question 22. The diagram shows the electromagnetic spectrum. The numbers indicate the appropriate wavelength of the at the boundaries between the various regions of the spectrum. For a device to be able to make use of electromagnetic radiation, it needs an areal of approximately the same size as the wavelength of the radiation it is designed to work with. Which statement is correct? A mobile phone uses radiation from region P. Okay, 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 okay. And now we have to identify the different regions. The first one is let's see. The first one is radio wave. That should be P. The second one is microwave. After microwave, we have infrared. After infrared, we have visible light. After visible light, we have ultraviolet. After ultraviolet, we have X-rays. After X-rays, we have gamma rays. Now, radio waves is used for radio communication. So option A, a mobile phone uses radiation from region P. That is correct. Option B, a television satellite dish uses radiation from region Q. Region Q is microwave. No, 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 no. Option C, the receptor cells is in an eye uses radiation from region R. R is infrared and the eye does not use infrared. Option D, the remote controller for a television uses radiation from region U. X-ray. No, your remote controller does not use region X-ray. Region U is X-ray. Your remote controller does not use X-ray. Your remote controller uses infrared. So only option A is correct. So question 22 is A. Question 23. Microwaves and X-rays are regions of the electromagnetic spectrum. Which statement about microwaves and X-rays is correct? A. Microwaves and X-rays have the same frequency. That is not correct. Option B. Microwaves and X-rays travel at the same speed in vacuum. Yes, all electromagnetic waves travel at the speed of light in vacuum, which is 300 million meters per second. Okay, so that is the correct answer. That should be the correct one. Let's just go to C and D. Microwaves have shorter wavelength than X-rays. No. Microwaves travel at slower speed. No, no, no. They travel at the same speed. Question 24. An observer stands at the finish line of a 100 meters race. He wants to time the winner's run. He starts his stopwatch as soon as he sees the smoke from the starting gun instead of when he hears the bang. What is the reason for doing this? An observer stands at the finish line of 100-meter race. He starts the time. He wants to time the winner's run. He starts his stopwatch as soon as he sees the smoke. As soon as he sees the smoke from the starting gun, instead of when he hears the bang. Why did he do that? You know, he sees, seeing that involves light rays, and hearing the bang that involves sound waves. What's the speed of sound? The speed of sound in air is around 300 to 340 meters per second. What is the speed of light? The speed of light is 300 million meters per second. That tells you that light travels faster than sound. In fact, the speed of light is close to a million times bigger, larger, faster. Light is about a million times faster than sound. So if he shoots his gun, if it starts the timer, rather, immediately he sees the light, the smoke, that means he is starting the timer immediately the race is starting. Okay. If it doesn't start it immediately, there will be a time delay because he's at a distance of 100 meters away. So there will be a time delay of approximately 0.3 seconds. Okay. So in order to avoid this error, that's why he's using the light. Okay, that's why he's using light rays. That is when he sees the smoke. You know, light, seeing the smoke involves light rays, and hearing the bang involves sound. So, option A, light travels much faster than sound, which is the correct answer. I don't need to check the rest. 25. Which description of a current in a metal is correct? A. Flow of electrons. B. Flow of molecules. C. Flow of positive atom. D. Flow of protons. A current is as a result of flow of electrons. Why? Because electric current itself is defined as the rate of flow of electric charges with time, okay, flow of electric charges, and those electric charges are referred to the electron, the negative charges, okay. So electric current is due to the rate of flow of electrons through a circuit. The diagram shows a circuit containing a variable resistor, this is a variable resistor, connected to a variable power supply, this is a variable power supply. It's fine. The table shows the current for different values of potential difference and the resistance. What is the order of current from smallest to largest? You know, from Ohm's law states that V is equal to IR. So if you are looking for the current, I equals to V over R. Now let's divide voltage by the resistance. 3.6 divided by 12, the first case, if you divide the voltage of 3.6 by 12, what would that give you? 36 divided by 12 gives you 3. So 3.6 divided by 12 will give you 0.3. So our first current is 0.3 amperes. The second one, 1.2 divided by 12, that will give you 0.1 ampere. And the last one, 3.6 divided by 6, that will give you 30 divided by 6. That will give you 0.6 ampere. So you see I3 is the biggest. Okay, what is the order of current from smallest? The smallest is I2, followed by I1, followed by I3, which is option C. Question 27. The EMF of the cell in this circuit is 1.5 volts. What does EMF stand for? Electromagnet? No. No. Electromotive field? No. Electromotive force. Perfect. That's the meaning of EMF. Number 28. A negatively charged plastic rod P is placed above a positively charged plastic rod Q. What are the directions of the electrostatic forces on rod P and on rod Q? Direction of electrostatic forces, no, Q is positively charged, P is negatively charged, and take note that since they are of opposite charges, what happens? There will be force of attraction. According to the law of electrostatic charges, unlike charges unlike charges attract, while like charges or similar charges repel. So here there will be attraction. That means the force on Q will be in a direction that is taking it towards P, and the force on P will be in a direction, this is the force on Q, and the force on P will be in a direction that is taking it towards Q. That means the force on P will be downwards and the force on Q will be upwards. So force on Q will be upwards, force on P will be downwards. That makes option B the correct answer. Number 29. A student finds the resistance of a resistor. Which circuit is used to measure the potential difference across the resistor and the current in it? Okay, so to measure the potential difference, your voltmeter must be connected in parallel with the resistor, so which is correct, okay? But the ammeter must be in series. In this case, the ammeter is not correctly connected. So option C is the correct answer. You see the ammeter is in series with the resistor. Yeah, that means the current that flows out of the cell will flow through the resistor and flow through the ammeter. Also, the voltmeter is in parallel in order to read the potential difference across the resistor. Hence, option C is the only correct answer to this question. Let's go to the question 30. The circuit diagram shows a variable potential divider. The slider is moving from P towards Q. What happens to the reading on the voltmeter and the brightness of the lamp? You know, when you are sliding this, the slider moved from P towards Q. So when you are sliding from P towards Q, you are increasing the voltage. Yeah, you are trying to increase the voltage between P and Q. And increasing this voltage will make this lamp shine brighter. Okay? Increasing the voltage will make the lamp shine brighter. Good. So reading on voltmeter. Also, the voltmeter, you are increasing the voltage. That means the reading on the voltmeter would go up, it will increase. Yeah, so reading on voltmeter would increase and brightness of the lamp will increase, which makes option D the correct answer to this question. Question 31. The diagram shows a circuit containing a cell, a variable resistor, and two bulbs P and Q. The resistance of a variable resistor is increased. What happens to the brightness of each bulb? If you are increasing the resistance here, what does that mean? The effect of increasing the resistance is that less current will flow through P. Okay? Yeah, if the resistance of this variable resistor increases, then the current flowing through P will be reduced. You are cutting off, like you are reducing the current flowing through P. Okay? And what is the effect of that? Also, since you are reducing the current flowing through P, okay, that also means more current will flow through Q. More current will flow through Q. Okay, good. So Q becomes brighter while P will become dimmer. Yeah, the bulb P will be dimmer and sorry, the brightness of Q remains the same. Yeah, pardon me. The brightness of Q remains the same. Why? Because you are not increasing or reducing the current flowing through Q. Take note that there's no resistor here trying to limit the current flowing through Q. Okay, so the current flowing through Q remains the same. Yeah, that is what happens when the bulbs are connected in parallel. Okay, when you connect bulbs in parallel, so the current flowing here, some will go this way, while the one that will flow this way remains the same. Okay, so it is the one going through the lamp P that is reducing. The one going through Q remains the same. That's why the brightness of Q remains the same. Okay, while P will be dimmer. That makes B the correct answer to question 31. Question 32. Which diagram shows a circuit containing a battery, a fuse, and a buzzer? This a battery, a fuse, and a buzzer. This is a fuse, this is a buzzer, this is a battery. That means option D is the correct answer. Okay, good. Question 33. What is a fuse used for in an electric circuit? To protect or to limit the current flowing. Okay, you are trying to limit, you put a limit to the current that can flow in the circuit. Option A, to increase the circuit resistance. No, to prevent short circuits, to reduce power loss, to stop cables from overheating. Okay, in case of D, in 33, D is meaningful because truly um, fuses put a limit to the current flowing in the circuit. And once you put a limit, then you are trying to prevent too much current from flowing through the wires or the cables. Okay, and when you are preventing too much current from flowing, that means you are preventing overheating. Because when too much current flows, the cables begin to overheat. You understand it? Good. To prevent short circuits, what you need is perfect insulation. When you insulate the circuit, there will be no short circuit. Okay, I'm talking about this one. To prevent short circuit, you prevent short circuiting by ensuring perfect insulation. Okay, because short circuit would cause too much current to be drawn. Okay, so the fuse can also offer protection to prevent much current to be drawn during short circuit. But the main objective of a fuse is to prevent overheating by placing a limit on the current that can flow in the circuit. Question 34. The diagram represents a transformer. Which row shows materials suitable for making the core and the primary coil? The core should be soft iron core and the primary coil should be copper. Copper is the appropriate material for making the coil. Let's see. Option A, iron, then copper. Oh, we have steel. Yeah, number 34. Option C is steel. So should we use steel? No. Why? Steel contains carbon. We don't want that. What we want is soft iron core, pure iron. Okay, when you have impurities like carbon, steel is iron that contains carbon, and once you have impurities like carbon in the core, they try to increase the eddy current that are produced in the core of the coil. Okay, you might not really learn much about eddy currents during your IGCSE, okay, but during your A levels, you have to understand the concept of eddy current and its effects. It causes the core to become overheated. Yeah, so the correct answer is option A. Iron, copper, pure iron, pure copper. The diagrams show the magnetic field lines around a wire carrying a current. Which diagram is correct? Let's see. According to the thumb rule, okay, according to the thumb rule, you assume that if you have a conductor and current is flowing through the conductor, when you grab that conductor with your right hand, okay, the direction of your thumb shows the direction of current, and the direction of your fingers around that conductor shows the direction of the field. So which one depicts this? Number one depicts this correctly. Is there another option that depicts this correctly? No. No other option. No, 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 no. Let me see. Number one depicts this correctly. Yes, that's fine. Also, number three depicts this correctly. That is when you hold the conductor upside down. That is what number three depicts, okay? It depicts the direction of current, also direction of the field. So look at the arrow of number three. So number one and three are correct, okay? D, one and three only. That's question 35. Number 36. A wire is placed between the poles of a magnet. Which statements are correct? Okay, so now we have a magnet and the north pole, south pole. So magnetic lines of force are in the direction of south pole. That means magnetic lines of force run from north pole to south pole. That's magnetic line of force for you. And number one, which statements are correct? An AC, a conductor is placed between the poles of a magnet. Which statements are correct? An AC current in the wire causes a changing force on it. Yes, when a current is flowing through this conductor, then there will be a force on it. A downward DC current in the wire causes a constant force. When you have a DC current, that is yes, when you have a downward DC current in the wire causes a constant force on it. Well, that is correct because you have a uniform field. That's correct. Number three, an AC current in the wire causes a changing force. That's also correct because the direction of AC keeps changing, and that would cause the force to keep changing. Yeah. Number three, an upward DC current in the wire causes a constant force on it. Well, that is also correct. 1, 2, and 3 are correct, okay? As long as current flows in the wire and the direction of current is perpendicular, that means the direction of current is in 90 degrees. It forms 90 degrees with the direction of the field. Then there will be maximum current. If direction of current and the direction of magnetic field are the same, then there will be no force, okay? But as long as the direction of current and direction of the field are inclined at an angle, then there will be force. If direction of current and direction of field are inclined at angle 90 degrees, then the force between those two will be maximum, okay? But here, we are not really interested in that. We are just interested in whether there will be force in each of these. And option D is the correct answer. Three of them are correct. An AC causes changing force. A DC causes a constant force, okay? Irrespective of the direction of the DC, a DC will cause a constant force, okay? Because the direction of the field and the direction of the current are perpendicular to each other. Question 37. The nuclide notation for the isotope lithium-7 is shown. So we have lithium-7 3. How many neutrons are there in an atom of lithium-7? The mass number of an atom is number of proton plus number of neutron. If you look at this, what you have here, this shows that the number of protons is the atomic number. Atomic number is 3, that means there are 3 protons. So if there are 3 protons, how many neutrons do you think there will be? The number of neutrons is mass number minus number of protons. The mass number is 7, the number of protons is 3, 7 minus 3 gives us 4. Hence, there are 4 neutrons. B is the correct answer. Question 38. A radioactive material is emitting alpha particles. The radioactive material is used in a demonstration in a school laboratory experiment. Which safety precaution must be taken by the person carrying out the experiment? Okay, so how would you prevent alpha particles from hitting you? What material would stop alpha particles? Option A, handle the salt Handle the source with tongs. No, the alpha particle will still get to you. Option B, place the source in a heat-proof material. No, we are not interested in heat. These are alpha particles, okay? Alpha particles are helium nuclei, helium 2 plus. And heat, it has nothing to do with heat proof. Option C, surround the experiment with lead screen. That's correct. So when you surround this experiment with lead screen, the lead will trap the radioactive material, okay? The lead will trap the radioactive material, it will trap the radiation. Yeah, this helium nuclei will not be able to pass through because the lead will capture all of them, okay? Yeah. Option, wear goggles, of course not. Goggles have no effect on this, okay? Option 39, the graph shows how goggles are not the appropriate way of protection. Of course, when you are wearing when you wear a lead suit, you can also wear goggles that are made of materials that can shield you from this. But wearing only your goggles has no effect when your entire body is exposed to radiation. That's why you are not picking goggles. Question 39. The graph shows how the count rate of a radioactive isotope changes with time. What is the half-life of the isotope? Half-life is the time taken for half of the material to disintegrate. So initially, if you look at the number of materials present initially from the very beginning, we have 40, 50. This should be 53. Initially, we have 53. Half of 53 will be what? 53 divided by 2 will give you 26.5. So how long does it take to get to 26.5? Oh, it has even been pointed out here. Yeah, this should be your 26.5. So that is time in seconds. That's 2 seconds. That's 2 seconds. Option A is the correct answer. It takes 2 seconds for half of this material to disintegrate. Question 40. A student measures the count rate near a radioactive source using a detector of ionizing radiation. The diagram shows the arrangement. Radioactive source, detector, counter. The counter reads 75 counts per minute. When the source is taken away, the reading on the counter decreases to 5 counts per minute. What was the rate of emission from the radioactive source when the reading is corrected for background radiation? These 5 counts, when the counter was taken away, represents the contribution from background radiation, okay? Why this was the reading we got. So if you minus what we got for background radiation from the original value, so from what was read on the counter minus error that was given in, error that came in through background radiation. 75 minus 5 gives you 70. So we have C, which is 70 counts per minute. So we have finished answering all the questions on your physics IGCSE core paper October November 2022 question. Of course, we spent more than 45 minutes. It's because I was explaining. But when you are doing this in your example, you should spend far less than that. Okay, so the next paper we'll be dealing with paper 21, which is for those the multiple choice question for students taking the extended exam. After that, then we take paper 31, on and on and on, 41, on and on till we finish the October November 2022 series. Stay tuned for the next video. Thank you for watching. Ensure you subscribe to this video, to this channel. Subscribe. Thank you.